This is an example from section 7.8 where we're going to look to find the inverse of a 3 by 3 matrix. Here we have our matrix A, and while the question doesn't say and demonstrate that you've successfully found the inverse, we'll do that because it's a great way to check your work to make sure that you got it right. So we'll start off as usual with our 3 by 3 on the left side. 1, 1, 1, 2, 1, minus 1, minus 1, 0, 1. And then to the right of this, we place the 3 by 3 identity matrix. So 1, 0, 0, 0, 1, 0, 0, 0, 1. So you'll see those right 9 numbers are the identity matrix. And now we perform Gaussian elimination on this in order to advance the process. So I have limited space with which to work here in my video making, so I'm going to take my steps one at a time. I don't make any changes in the first row. 1, 1, 1, 1, 0, 0. Now in the second row, what I'm going to do is take minus 2 times row 1 plus the old row 2, and that'll be my first step in Gaussian elimination. And that indeed does say minus 2 times 1 plus 2 gives me 0. Minus 2 times 1 plus 1 is minus 1. Minus 2 times 1 minus 1 is minus 3. Minus 2 times 1 plus 0 is minus 2. Then we just continue the rest of that row since we had zeros in our initial row. Now we need to get rid of the minus 1 that is the first element in the final row, the third row. So we're going to get rid of that minus 1 by adding the old row 1 plus the old row 3 and let that become our new row 3. So we get 0, 1, 2, 1, 0, 1. And that's our next step. At this point I need to raise up my screen for a little more room, and so we'll make this be our next step. So again, we continue the first row, and we don't have any more steps to perform at this point in the next row. But in the last row, we need to get rid of the 1. That's the second component of the third row. So we'll do that by taking the previous row 2 and adding the previous row 3, and that'll be our new row 3. So 0, 0, minus 1, minus 1, 1, 1. Okay, at that point, if we were just trying to perform Gaussian elimination, we'd be done. But because in the in this method, where we're trying to find the inverse of A, we need to continue to perform row operations until the left side looks like the identity matrix. And we're going to do this one step at a time. So what do I need to do to the bottom row in order to turn the first 3 components to be the first 3 components of the identity matrix? We just need to multiply the bottom row 3 by negative 1. So 0, 0, 1, 1, minus 1, minus 1. And we have that row actually complete. At this point, because I've been taking this step by step, I'm going to continue to do so. So I'll just copy the previous row 2 and the previous row 1 so that we're doing one step at a time. But now we're ready to perform more, so I'll make room for 2 more steps. So what we'd like to do now is use the row 3 that we just produced in order to get rid of the -3 and the 1 that lie above that. So we'll do that one step at a time. So row 3 is going to stay the same. But what we're going to do now is take 3 of row 3 and add it to the previous 3 of this row 3 and add it of this row 3 and add it to the previous row 2. So when we do that, we get the first 2 terms aren't changed yet. And now what we're going to do is take 3 of the previous row 3 and add it to this previous row 2, and that'll give us a 0 here. That's what we needed. And we'll take 3 times 1 is 3 plus -2 is 1. 3 times -3 plus, whoops, 3 times -3, sorry, 3 times -1 is -3 plus 1 is -2. 3 times -1 plus 0 is -3. And while I'm at it, I'm going to get rid of the 1, that's the third element of row 1, by taking the previous row 1 and subtracting the previous row 3. So that's 1, 1, 0. 1 minus 1 is 0. 0 minus a -1 is 1. 0 minus a -1 is 1. So, at this point, the step I'm going to perform next isn't necessarily what everybody would do, but I can see that it'll be easiest if I just keep row 3 the same for the moment. 0, 0, 1, 1, minus 1, minus 1. And I'll keep row 2 as is for now. 0, whoops, 0, minus 1, 0, 1, minus 2, minus 3. And for the new row 1, what I'm going to do is take the old row 1 and the old row 2 and add them. So I get 1, 0, 0, 1, minus 1, minus 2. Again, I took the old row 1 plus the old row 2 in order to get that. And at this point, I'm just one step away from being done. If you take a look at our previous result, the left half of this almost looks like the identity matrix, except that I need to take row 2 and multiply it by -1. So when I take that last step, I get 0, 1, 0, minus 1, 2, 3, and row 1 remains the same as the last step. 1, minus 1, 2. Which says that our A inverse is just the left half of what we've just produced. How do we know that? Because it's the right half of what we just produced. We know that's the inverse because this has become the identity matrix. So this is now A inverse. So A inverse is equal to one minus 1, 2, minus 1, 2, 3, 1, minus 1, minus 1. And the way we check that, it's always good to check your work in something like this, is we'll take A times A times A inverse, and we'll multiply them. And our A was 1, 1, 1, 2, 1, minus 1, minus 1, 0, 1, and we'll multiply that by 1, minus 1, 2, minus 1, 2, 3, 1, minus 1, minus 1, and see what we get. So here we have, for our first term in the upper left, we have 1 minus 1 plus 1 is 1. For the next term, we have our row 1, 1, 1, which we multiply by the second column, minus 2, which we multiply by the second column, minus 1, 2, minus 1. So we get minus 1 plus 2 minus 1 is 0. And for the last component here, we get 2 plus, okay, I got a mistake. I'm going to change something here. If you'll notice, I made a sign error. See this minus 2? I just dropped it. So that's actually our result. So I'm going to change right here. Checking your work helps, because now I can see that when I make that correction, I do get 0. And then I'll look at the second row of this product, and I now get 2 times 1 plus 1 times minus 1 plus minus 1 times 1, that's 0. And then for our next component we have minus 2 plus 2 plus 1, and that's 1. For our last component we get minus 4 plus 3 plus 1 is 0. And for our last row we get minus 1 plus 1, then we get minus 1, nope, we get plus 1, minus 1, and last we get 2 minus 1 is 1, and indeed we get the identity matrix, so that is the correct answer. Glad we checked, I caught my mistake and found the correct inverse here.